Hey, let's finish off this lesson with derivatives of logarithms. Um, we're going to basically look at what we already know and apply that information to something different. And again, I think that's the beauty of math, is that you learn something in one area, and then you apply that to all kinds of different areas. So we're gonna apply what we already know to find the answer for something different. So we're going to use a lot of skills here. First of all, your base is 3 and the exponent is y, so 3 to the y equals x. We're just going to change forms to be an exponential form. And then we're going to change it to a natural log form, because that's what the lesson's about, is how do you make this a natural log question? And you make a natural log question by taking the natural log of both sides. And then back in math 30, you remember that you had the rule, whatever the power is, it multiplies in front. So the last thing we want to do is we actually want to solve for y. So let's move the natural log from the left side to the right side. So it's with the natural log of x. So again, when you move it to the other side, it becomes a fraction. So I got all kinds of stuff showing here, but I have this function now, y equals 1 over natural log of 3 times by the natural log of x. I want to find that derivative. One of the most confusing parts is that this 1 over natural log of 3 is actually a number, it's a constant. So I got this little example over here to remind you that when you have a constant like 5 in the question and you go to do a derivative, this 5 doesn't change. So 5 that you started with stays as 5, and it multiplies by the derivative of the original of the function. So it becomes 5 times 3x squared is 15x squared. So this 1 over natural log of 3 just stays 1 over natural log of 3 because it's a constant. And then the other layer is you got the natural log of x. So again, same thing, and you got the natural log of x, its derivative is just 1 over x. So those are the layers that we kind of went through when we're simplifying the expression. Derivative of y is dy dx. Derivative of a constant stays as a constant. Derivative of natural log of x is 1 over x. So that's the answer. So again, even though it didn't look like we started with y equals the log of x to the base 3, that's what we really started with. We just changed forms and we found an answer. So if you go back to the original question, what is the derivative of y equals log of x to the base 3? Your answer needs to be the same as the answer you found using your new skills. Your answer needs to be 1 times 1 over natural log of 3 times by x. So what we're saying here then is that if your base is not base e, is you got to deal with a stretch factor. And the stretch factor when you have log base 3 is natural log of 3. If you have log of any other base, log of base b, you have to deal with the stretch factor. So the two rules that you have to follow now, if your base is not e, is what's the stretch factor? So it's 1 over natural log of b, and what's the derivative of x? In this case, what's the derivative of natural log of x is 1 over x. Okay, so that's how you deal with things that aren't base e. And then our last example here, this is base 10. So again, we're talking about base 10. Your stretch is 1 over log. And again, we don't write as 1 over log. It's usually there's a base 10 here. So log base 10. Your stretch is natural log base 10. And then the function that you start with, the rule's the same. It's 1 over the function. So it's 1 over x squared plus x with 1 over its stretch factor, and then times by the derivative of x squared plus x, which is 2x plus 1. So as your questions, as we add some layers, if you change your base from base e to base 3 to base 10, just put your stretch factor in. The other rules are the same. It's 1 over the function times by the derivative of the function. This rule of the stretch factor actually works with base e as well, because if you put the natural log of base e in here, that would just be 1. So your stretch factor is 1. All right, that's it for the examples. Three mini lessons there. I hope you learned a few things, and I hope you appreciate all the layers that kind of exist when we do log questions.